Algebra 3, Chapter 3, Section 1, Quadratic Functions and Models. Now you should be very familiar with quadratic functions. As a review, it is a second-degree polynomial, which means the highest power is a 2. The parent function is y equals x squared. The general or standard form of the equation is f of x equals ax squared plus bx plus c, where a, b, and c are going to be real numbers, rational numbers. The graph of a quadratic function is a parabola. And here's the parabola. It has a vertex and it has an axis of symmetry. The vertex is the turning point. It'll be either the highest or lowest point on the parabola, and it's where it changes from decreasing to increasing or increasing to decreasing. It'll be the lowest point if the parabola opens up, like you see here. It'll be the highest point if the parabola opens down. The axis of symmetry splits the parabola in two equal pieces right down the middle, and the two pieces are mirror images of each other. In this case, the axis of symmetry is the y-axis. A quadratic function can be expressed in vertex form. Now, our book calls this standard form. I'm not really sure why but most books will call this vertex form. The form is f of x equals a times x minus h squared plus k, where hk is the vertex of the parabola and x equals h is the axis of symmetry. The reason this is generally called vertex form is because you can look at the equation and you can pull the vertex right out of it. It's hk. You don't have to do any calculations or graphs to find the vertex. To change a quadratic form into a function into vertex form, we're going to use the same process that we used for completing the square. This is one way of doing things. Or we can use the fact that h, the h of the hk, equals negative b over 2a. Now we could prove that, or you can just accept it, but it is negative b over 2a. That gives you the x value of the vertex. Then what you would do is you would put that x value into the standard form that you were given, and you would find the y value, and that would give you the k, and then the a will be the same for both. This is really the easier method to do it. Again, you could use completing the square. This method is much simpler and much faster. Use a graphing utility to graph this quadratic function. You're going to identify the vertex, the axis of symmetry, and the x-intercepts, and we're going to write the quadratic function in standard form, which, again, the book calls it standard form. It's generally called vertex form, that y equals a x minus h squared plus k. Pause the recording, give this a try, and resume to check your answer. Okay, our vertex is -4, -5, and again, the easy way to find that is to take the original equation, x squared plus 8x plus 11, the h, the x value of the vertex, is going to be negative b over 2a, so negative 8 over 2 times 1, which is negative 4. To get the negative 5, put negative 4 in for x, and the result will be negative 5. So our vertex is -4, -5, which allows us to write it in the vertex form. The a that goes in front of the parentheses is the same as the a in front of the x squared, which in this case is 1. So we have x plus 4 squared minus 5. You see the graph there. Our axis of symmetry is -4. It will always be the x value of the vertex. And our intercepts are -4 plus or minus the square root of 5 and 0. And how you find that is, again, you're going to solve it for 0. You're going to set x squared plus 8x plus 11, or the vertex form, equal to 0 and solve. Okay, now try it with this particular function here. Let me make a suggestion. If you're going to use the easy method for finding the vertex, I suggest you distribute the 1/2 through first. Pause the recording, give it a try, and resume to check your answer. Okay, so distributing it through, we would have 1/2 x squared plus 2x minus 1. Our vertex is negative b over 2a, our x value, which would be -2 over 2a, 2 times 1/2, which is 1, so -2 over 1, which is -2. put -2 in for x and get the y value of -3. So our vertex is -2, -3. To change the equation, the a is going to be the same, so the a is 1/2. X plus 2, there's that x minus h squared minus 3. You see the graph, the axis of symmetry is -2, x equals -2, which is the same as the x value of the vertex. And again, to find the x-intercepts, you're going to need to set the equation equal to 0 and solve, and we get -2 plus or minus the square root of 6, 0. You can find the x-intercepts of the graph by setting the function equal to 0 and solving for x, as we just said. And you can find the y-intercepts by putting a 0 in for x and solving for y. An easier way to do it, the y-intercept will always be the constant term of the quadratic function when it's written in standard form. When it's written as ax squared plus bx plus c, c will always be the y-intercept. You can write the equation of a parabola if you're given the vertex and one other point that it passes through. This is actually not that difficult. What you do is you take the vertex form of the equation, the a times x minus h squared plus k. You'll put the vertex values in the place of h and k, and the other point they give you, you'll put in place of x and y, and then you're going to solve for a. And then once you know a, h, and k, write the equation. So, with that information I just gave you, why don't you give this a try? Pause the recording, see if you can write the equation, and then resume the recording to see how you did. Okay, we can see from the graph that -2, 2 is the vertex, and they didn't give us a point, but we can see that the point goes through the that the graph goes through the point -1, 0. It also goes through -3, 0, so that would be another easy one to use. You could probably even use the point 0, -6. You just want to pick a point that the graph clearly goes through and try to make it an easy point. So we'll put in -2, 2 for h and k. We'll put in -1 and 0 for x and y, and then solve for a, and we get that a is -2. So our equation is y equals -2, x plus 2 squared plus 2. Okay, now we're going to do really the same thing, except this time instead of a picture of the graph, they actually gave us the vertex and the point. You're going to use the exact same process, so give both of these a try. Pause the recording while you're doing them and resume to check your answer. Okay, just look over these. We're using the same exact method we used before, and you can see the equations worked out there. See how you did, check your work. If you need to look over these a little longer, then pause the recording. If not, then just continue on. Okay, now you're going to use a graphing utility, which means your calculator, to graph the quadratic function. You're going to find the x-intercepts and compare them with the solutions of the corresponding quadratic equation when f of x equals 0. In other words, you're going to graph this on your calculator and use the calculate 0 function on the calculator, and then you're also going to do x squared minus 4x equals 0 and solve, and you're going to compare the solutions and see that you got the same thing. Pause the recording, give this a try, and resume to check your answers. So our x-intercepts are 0, 0, and 4, 0 from the graph. Setting the equation equal to 0, we can factor out the x, and then we get x equals 0 or x equals 4. Same exact thing. The x-intercepts and the solutions of the function set equal to 0 are the same. And the reason they're having you do this is they want you to make that connection. X-intercepts and zeros are the same thing. In this example, we're going to find two quadratic functions, one that opens upward and one that opens downward, whose graphs have the given x-intercepts. Okay, so let me give you a hint on this. Remember, if the solutions are -1 and 3, then the factors we got them from must have been x plus 1 and x minus 3. And if you multiply those factors together, you're going to get a quadratic equation that has those two x-intercepts. Now, as far as opening upwards and downwards, you can, once you get your basic quadratic function, once you've multiplied those two factors out, if you multiply through by a positive number, you'll have a graph that opens upward. If you multiply through by a negative number, you'll have a graph that opens downward. Pause the recording and give this a try, and then resume to see how you did. Okay, so what we did, again, was we multiplied x minus -1 times x minus 3. And for the opening upward one, we just left it at that. Now, you could have multiplied through by any positive number you wanted to. Once you get x squared minus 2x minus 3, you can multiply all of that by any positive number and have a graph that opens upward and be a correct answer. For the downward one, what we need to do after we get x squared plus 2x or minus 2x minus 3 is we need to multiply through by a negative number. Now, they multiplied through by -1, so that gives us negative x squared plus 2x plus 3. You could have multiplied by any negative number and gotten the same results, and gotten results that would satisfy the example. Two quadratic functions, one that opens upwards and downwards, that have the given x-intercepts. And again, this is the same type of problem as we just did. So give this one a try. Pause the recording to do it, and then resume to check your answer. And again, we're multiplying x minus -3 times x minus -1/2. They're multiplying that through by 2, really just to get rid of the fraction. And that's fine, not a problem there. And again, for the negative, for the opening downward, we're going to multiply through by a negative number. So notice what they did, really. You just need to multiply the things together one time, and then to get the downward, multiply everything by -1, and you've got your answer. A parabola will either have a maximum or minimum point. This point is going to be the vertex of the parabola. The maximum or minimum is the y value, but you can give it to me as a point just to be safe if you want to. You never list it as simply the x value. You tell me when they ask for the value, you give me the y value, or you give me the point. It'll be a maximum if your x squared term is negative, because it'll open downward, and so you'll have a high point. It'll be a minimum if your x squared term is positive, because it'll open upward and have a lowest point. So here's our example. We have the path of a diver given by this function. F of x is the height in feet, and x is the horizontal distance from the end of the diving board. What is the maximum height of the diver? So really what you want to find here is the vertex, and there's several ways to do it. Pause the recording, give this a try, and resume to check your answer. All right, so the way they're finding the vertex is they're using the fact that the x value is negative b over 2a, which is negative 24/9 over 2 times negative 4/9, and that simplifies to 3. To find the y value, put in 3 for x, and you get 16 feet. So the vertex occurs at the point 316. The diver's maximum height is 16 feet. The manufacturer of lighting fixtures has a daily production cost of C equals 800 minus 10x plus 0.25x squared, where C is the total cost in dollars and x is the number of units produced. How many fixtures should be produced each day to yield a minimum cost? So this time we want to find the minimum of the vertex of the parabola. Pause the recording, give this a try, and resume to check your answer. Okay, so first thing I want to do is I want to rewrite it so it's in general or standard form with the x squared first, descending form. Then I'm going to use negative b over 2a, and I get negative 10 over 2 times 0.25, and that simplifies to 20. So when he produces 20 fixtures, he has a minimum cost. Now, that's all we're finding here because the question said how many fixtures should be produced each day to yield a minimum cost. If they want to know what the minimum cost is, then you'll put the 20 back into the equation and find that.